cannot find it anymore. Oh, now I see. Okay. Hidden plus button.
Yes. If it's a webinar, I can actually change the background for everyone. Okay, it looks like we are live. You two ready? All right, fantastic. Hello, everyone, and welcome to today's live stream. So today I am going to be, supposedly anyway, live coding a scalable NoSQL database in TypeScript. So what I'm going to do now is share my screen and review some of the requirements of this scalable NoSQL database with you. And then I will introduce you to my colleagues here who will hopefully be available to help me or heckle me, as the case may be, as we make some progress on this exciting live coding challenge. All right. Here we have, hopefully you can see my screen. Daniel or Maxim, you want to confirm that?
Yes, you can see it.
All right, fantastic. So today is Friday, December 12th, and it is just past 9 a.m. And my mission today is in 2 hours to build a scalable NoSQL database in TypeScript. And the requirements of this challenge are that, number one, it be horizontally scalable. That means we can deploy this across some large number of nodes so that we can end up storing a lot of data in this NoSQL database. And number two, it needs to be able to survive the loss of any node. So if a node goes down, the server crashes, the CPU catches on fire, or whatever happens, we need to not lose any data. And we need to have minimal disruption to activities in the database. We need to support point lookups and enumeration. And in a perfect world, we would actually go beyond that and support some form of querying the data. I don't think we're going to have time to do that in 2 hours today, but let's see, you never know. It should be consistent and highly available in a cap sense. We should leverage RAM, but fall back to disk in order to minimize costs. So we want to keep stuff in memory as much as we can. But when we can't do that any longer, we want to push stuff down to disk, which will, of course, enable us to scale beyond the contents of the RAM allocation across all the nodes. And then we want to rely on no proprietary software. And actually, I want to go beyond that and say we don't even want to rely on open source software to the extent that it would make this problem trivial. We don't want to just create an API around Cassandra or MongoDB or Redis. We actually want to build something new. And for those of you who are joining live, I highly recommend joining us on Discord. You can get access to that with the bit.ly link there, or it's right here. It's the same link up there. So hop over to Discord, and you are free to heckle or maybe help as we make progress through this live coding challenge. So joining me today is Daniel Vygotsky, who is lead engineer of Golem, the open source solution that I'm going to be relying on to help me actually get as much of this done as I possibly can. And Daniel, want to say a few words to introduce yourself?
Yes, thank you. So, as you said, I'm a lead engineer of Golem, which we started working on about 2.5 years ago, I think. And yeah, but before that, I was mostly a Scala developer working on various projects. And even before that, let's even not talk about that at the moment. So about Golem, I think you are not going to run into any issues, so I don't know why I'm here, but let's see what happens.
We'll see about that. Okay, thank you, Daniel. Maxim.
Hi, I'm Maxim. Happy to be here. So I joined the Golem team a bit more recently than Daniel. I joined only a year ago, actually, after completing one of the bounties that Golem had opened on their repository. So if you're interested in doing open source work and maybe even getting a job out of it, I do recommend checking out the various tickets that we have open in our repos. So enjoy the demo.
Thank you, Maxim. So I guess I'm ready to begin. A few disclaimers are in order. First off, I will be using a pre-release version of Golem compiled from main. So I needed to do this because I wanted to use some of the latest features that are coming to Golem 1.4, which is going to be released in just over a week. So I'm going to blame any technical glitches. First, I'm going to blame them on the pre-release state of the software. If that doesn't work, I'm going to blame them on Daniel or maybe Maxim, depending on what sort of glitch I run into. Second off, another disclaimer is I don't actually know TypeScript. And as far as I know, Daniel doesn't really know TypeScript either. Maxim, can you help me if I get stuck?
Yeah, I think so.
You know enough
No promises,
TypeScript
though.
to get by? Okay, fantastic. And if you are joining us in our Discord, you're free to help me that way. If I get stuck and I clearly don't know what I'm doing, then please tell me a better way to do something in TypeScript. Thankfully, I do have Copilot on VS Code, so that should save me from any obvious blunders and allow me to make some progress if I get stuck. All right, let's go ahead and start. I'm going to open up a terminal window here, and I am in a new and empty directory. And what I'm going to do is I'm actually going to use Golem's command line interface in order to create a template project. And I'm doing this because there's certain scaffolding that is necessary when you're building for Golem. And that just includes like different libraries and build instructions and whatnot. I don't want to have to worry about that right now. So I just want to use an off-the-shelf template. I am going to be using TypeScript, even though in this pre-release version, you probably will see that there's also support for Rust. Today, I am going to be using TypeScript. So Golem is the name of our command line tool, and you can see some of the different options here. And the one I want is under app. So I want to create a new application today. So I'm going to do Golem app, and then that shows me all the options under here. And what I want to do is actually create a new app using an existing template. So that would be Golem app new. And then I have to specify a name, or actually I can just hit that. The name I want is NoSQL. And then I actually want to choose TypeScript. And I'm going to use the default template, which is just a very simple application that just has a counter in it. I'll show you what that looks like in a second. I'll package name. Okay. I'm going to go with JD Goes NoSQL. Okay, so I'm done. It has prompted me to actually add a component here under this new application. So what that means is an application consists of one or more components, and component is just a component of your overall application. For a simple application like a scalable NoSQL database, I think we'll just be using a single component here. So I'm done. I want to create the application. And then I'm just going to poke around here and see what I see. Okay, so I can see that the command line interface created a new directory called NoSQL. I'm going to go in there and see what's in there. Actually, I'll just do this. I'll do this. Okay. So I can see here a single source folder. I've got some errors here, which are caused by probably me not having npm installed. I'm going to open up the single TypeScript file in here and just see what's in here. There we go. Okay, so this is the template that I chose to create this new application from. Now, I'll walk you through this in a second, but I actually want to get it compiling first. So what I'm going to do is run Golem app build, and this is going to go through both the build for this TypeScript project, but it's also going to do some other stuff that are Golem specific and make sure that there are no problems. I'm going to hit that, see what happens. Just give it a second here to run through all of its different steps. Everything's good so far. All right, ta-da. Okay, we're good. And you can see here that all different components of this succeeded. So we don't have any more errors anymore. I think NPM was installed. So now all of this is compiling. Now that it's compiling, let me go ahead and walk you through the different components of this TypeScript file and explain to you how Golem looks at this. So Golem can be used to run a wide range of TypeScript applications, and you can copy paste huge amounts of code from other projects or libraries into your Golem project. But from Golem's perspective, the fundamental unit of computation and state is something called an agent. So Golem is basically an agent native runtime for TypeScript and Rust and any other language that it supports. And consequently, the way that it exposes APIs and the way that it supports RPC is through this fundamental unit of state and computation called an agent. And in our TypeScript SDK, how we chose to expose this functionality is through this agent decorator. So I have a class here, which is called counter agent that extends base agent. And I have decorated it with agent. And as a result, I have suddenly made this thing here available, visible to Golem. So Golem can see this. It can understand how to make one of these. It can understand any of the different methods that I have added to this agent. Agents have constructors and they have methods. And it can also facilitate communication, type-safe communication between agents in a Golem cluster. So I'm going to show you that in a second, but before I do, I'm going to have to deploy this application. I built it, but I need to deploy it to the Golem server. In my case, before I started this live stream, I actually spun up a local Golem server. It's very simple. You just do Golem server run, and you have a local Golem server that's running in the background right now in a different terminal window. So what I'm going to do here is simply type in Golem app deploy. And what I want to do typically when testing is to add this reset command line argument just to wipe out the state of my local Golem, delete some stuff that might be there as a result of my testing, and make sure that I have a clean, fresh slate in which to test this example agent. So I'm going to go run through this, and you can see when you go to do a deployment in Golem, it's going to tell you everything that's going to change. So what it does is actually a three-way diff. It looks at what's on your local system, it looks at what's on the server deployed in production, and it looks at what's on the server in the staging environment, and it tries to figure out, and first off, that what you're doing actually makes sense, but it tries to inform you about the exact changes that are going to occur to your infrastructure in the act of deploying this. And here you can see I've got, well, a new component. A lot of this won't make sense. I've got an API here, which I might talk about later, but I'm not going to go into this. And here's basically, I've got a single agent here with a single method, which is, this does not use currently TypeScript types. Look for Golem 1.5 to see TypeScript types here. But for now, I see this in a sort of generic RPC-like representation of the functionality in that TypeScript class. And then I see the planning has detected we're going to create this component, create this API, and create this deployment. So I'm going to just go ahead and continue with this and see if it succeeds. There's a domain inside this application manifest file. That's fine. I'm just going to accept yes for everything. Okay, so I've created a new deployment. I have now deployed this agent here on my local Golem server. So now Golem is now aware that there is an agent of this type, with this name, with this constructor, and that has a single method called increment. So I want to test and make sure that's actually working before I go about solving this problem. So I'm going to do Golem REPL. And Golem REPL is just our REPL that uses a scripting language called rib in order to allow you to interact with agents that are running inside a Golem environment. And in Golem 1.5, we'll have actually a TypeScript REPL here. But for now, we're just using rib because it understands the underlying structure of the data that's used by our RPC and everything. So here I can see that there is this thing called a counter agent, which comes directly from my code. And what I'm going to do is I'm actually going to create one of these counter agents. This constructor here allows me to pass in the name of the counter agent. And I'll explain, this actually has a significance in Golem. Constructor parameters in general have a significance. I'll explain that in a second, but for now, just think of this as being the ID of the counter. So I'm going to go ahead and create a single counter using this counter agent constructor. And I'm just going to call this counter 1, 2, 3. Okay, so that succeeded. So I have a counter. And obviously, there's a single method inside this counter agent class. So I can actually call that method here, c.increment. And I get back 1, which comes from the return value of this method. So let me just increment it a few more times. And you can see this is working. I can exit the REPL. I can restart the REPL. And then I can increment it again. I can see that the state of this agent has survived REPL, and it will survive anything, actually. So I can go ahead and kill Golem and restart it. I can restart my system, and that's not going to have any effect on the state of that agent, which is one of the guarantees that Golem provides. So Golem provides a few different guarantees. One of them is durable state. What does that mean? It means that all of the in-memory data that I'm storing inside this agent is actually stored durably. I don't have to persist it. I don't have to store this in a database or a log or a cache or anything like that. I can just store it in memory, and Golem will make sure that the state of this agent is persisted reliably and continuously. So the proper model to think about durable state is not occasional snapshotting. That would be one way of implementing this. Golem does not do occasional snapshots. Rather, it has a live, continuous replica of the state of this agent. That means as every single line of code is executing in my application, whatever sorts of changes those yield in the agent state are being replicated and stored redundantly. So that means that I can treat data that's in memory as every bit as reliable as data that I would manually store in a database. And of course, I don't have to store it in a database because it is as reliable as if it were stored in a database, just being stored here in memory. Okay, so another guarantee that Golem provides us with is so-called transactional code execution. So transactional code execution basically means that in any of my agent methods here, or actually any function in my entire TypeScript code, I can have a bunch of steps, and those steps will be executed in order to completion. And that happens regardless of all the different failure events that can happen that are beneath the level of my application. So for example, if I'm running Golem in Kubernetes and Kubernetes decides to kill a pod, that is not going to have any effect other than maybe increasing latency for the execution of code that I have running inside Golem. In addition, if there's a network failure or a server crash, or there's some sort of VM problem, or my application needs to be restarted because I changed config, or maybe the CPU catches fire or memory is defective, doesn't really matter. I have that guarantee that all of the code that I write and deploy on Golem is going to be executed transactionally, automatically fault tolerant to any sort of faults that occur beneath the level of my application. I don't need to write code in any particular way. I don't need to use any sort of decorators to get that. I don't need to use any sort of strings embedded randomly into my functions. I just get it everywhere pervasively and down to the level, actually even past the level of an expression. So this automatic sort of transactional code execution that I get is as fine-grained as you can possibly imagine. So I get these two properties, durable state and transactional code execution, without having to do anything for 100% of the code that I deploy on Golem. And this is going to be one of the keys that hopefully enables me to at least have a shot at building a scalable NoSQL database on top of Golem today. All right, now with that basic background information out of the way, let's do a few other things. All right, so I'm going to use the Golem command line tool to list agents that I have running. Let me just see here. This command was not working yesterday. Let me take my chances here. Ta-da, yes, fantastic. Okay, so I have a single agent here, and the agent name is as follows. Counter agent with that string quote. I'll explain that in a second. Component revision. I've only deployed one of these things into my local Golem server. This is when the agent was created, and this is its status. So right now, this agent actually does not exist in memory. Why? Because it hasn't done anything interesting in some period of time. So Golem will keep agents in memory for some period of time, but if you're not interacting with them, it goes ahead and puts them in cold storage to save you costs. So basically, you only pay infrastructure costs related to the number of active concurrent agents running across your Golem cluster. And this lets you have millions, tens of millions, hundreds of millions, billions of agents, of which only a subset are executing right now. From your point of view, you can treat agents as immortal, right? Assuming we don't update Golem or change anything that would break any sort of data, this agent will exist and can be interacted with its current version of state for all time. And what happens is if you interact with an agent that's in so-called cold storage, Golem just loads that into memory dynamically, and so it rematerializes it into RAM, puts it running on one of the nodes in the Golem cluster, and then I can just interact with it as if it were already there. The only thing that I see from my perspective is slightly increased latency. So if you have an agent that's in cold storage, you're interacting with it, it has to be rematerialized, then it's just a slight bit of latency, which we're going to make even less in the next version of Golem 1.5. It'll be very, very, very fast to rematerialize these agents when they have to be used again. So just a single agent right here. And that's, I think, all I want to show you with that. So there's one more thing I want to talk about before starting this challenge, and that is how agents are distributed and looked up across a Golem cluster. And I'm going to tell you something that is mostly true, but there are exceptions, but it's going to help you understand the basic way that Golem works. And it's going to give you some information on how to design distributed applications for Golem. And that has to do with the agent constructor. So here I have a constructor with a single parameter. First off, these are my parameters. I choose how many parameters my agents have, and I choose what their types are. So this is not something that Golem requires. It's my choice, what I put in this constructor. Second off, I can have as few or as many constructor parameters as I want. And how Golem will use those constructor parameters is it will take up all of them and it will say, okay, all of these collectively determine the identity of this agent, which is running inside a distributed Golem cluster. So this is, in a way, this parameter here represents the identity of every single agent. And you can see that actually down here. You can see under this thing called agent name, this is basically the agent identity, the fully qualified identity of this specific agent that is running inside my Golem cluster. You can see it's not just a combination of, or it's not just the constructor parameters, it is also the agent type name. So that's a name that I choose here. I chose counter agent, which means that if you want to think about it in one way, different types of agents have different namespaces. That's a way to think about it. Inside a Golem cluster, different types of agents have their own namespaces. Within any given agent type, that's its own namespace. And every agent inside that namespace is determined uniquely by the constructor parameters. And in this case, I just have a single constructor parameter value, which is this string. So that should allow you to make more sense of the behavior we were seeing in the Golem REPL. Right? Back in the Golem REPL, I said, hey, give me this counter agent. I asked Golem to give me this specific counter agent. And now I get back a reference to this agent, and I call methods like increment on it. And it is actually searching out and finding the agent wherever it exists across my entire Golem cluster and allowing me to interact with that specific agent by its type and by its constructor parameters. So type and constructor parameters represent identities and now allow me to look up and reference individual agents and therefore interact with them through their agent methods. So what do I get out of this? Well, I get a few things. Number one is, obviously you can see that Golem is aware of the existence of a type of agent called counter agent. It knows what the constructor is. It knows what the constructor requires. It knows how many methods there are here in this agent. It knows what the names of these methods are, what their input parameters are, and what their return types are. It knows all of this, and I can add additional metadata, which can be useful if I want these agents to be controlled by AI in MCP export or whatever. Then I can add like prompt information, description, etc., or even like open API documentation generation. All this information can be used in that. So, but beyond that, because Golem is aware of the structure of all of these different agents, their constructors, and their types, I'm actually able to do RPC in a type-safe fashion. What does that look like? Well, let me just show you an example here. So here, I want to remotely talk to an agent which is living somewhere inside the Golem cluster. I want to do that in a type-safe way. So the way I can do that is by using any one of a number of different constructors. The one I'm going to use is one called get, counter 1, 2, 3. And then I get back actually something here that looks like my agent. It replicates all of the methods, and I can call any of the methods here in a type-safe fashion. So in this case, I want to do counter increment. And okay, so what has happened in this little snippet is I have called this get constructor, which is going to take the same number and type of parameters of my agent constructor here. So because I just have a single parameter here that's a string, I only needed to specify this. And it has given me back a reference to this agent, which is in the general case running on a different node in the Golem cluster. And I'm able to directly interact with that just by calling methods. All of this is type safe. All of it's async. And The signatures here match exactly with the signatures as defined in my agent. So I have a very pleasant user development experience when I'm doing RPC in Go. What else to say about that? I think, okay, one more thing, which is I mentioned before that the correct way to understand these constructor parameters and the agent type is as an agent's identity, which means that if I were to delete this parameter and not have any parameter here, then because this agent type has no constructor parameters, when I go to get it, I'm not allowed to specify anything. And there's only a single one of these inside a Golem cluster. So effectively, I've created a singleton agent. Singleton agents are generally not good ideas. Occasionally, they're useful, but a singleton agent, if you're directing a lot of traffic to an agent that is running on a single machine, then obviously that can create lots of contention. There could be lots of overhead. So that's not a good idea, but there are occasionally times where that's something that you'll want to do as part of your overall agent architecture. All right, another fine point is that even though, nope, that's not what I. That doesn't seem right.
It's supposed to be called get phantom.
It is. It's not auto-completing. Let me just see if it compiles. Pre-release, I guess. Right. Yeah, I'm not sure. So this is a new feature that will definitely be in 1.4. I don't know why I'm having trouble making this work now. But Golem also supports this notion in 1.4. It will support this notion called phantom agent. And a phantom agent is basically adds a UUID to the agent constructor parameters. So this is useful in cases where the constructor parameters are not enough. You want to uniquely identify an agent with some sort of UUID so that you can have many, many different agents that all have the same constructor parameters. So why would you want that? Well, you would want that in a number of different cases. For example, if you had built an API on top one of your agents and you wanted every single request to be served by a different agent, then maybe your constructor parameters would not uniquely identify that request. Of course, you could always add something like a request ID here, and you could do it that way, but you don't have to. Golem has this notion called phantom agents, which lets you keep this nice and clean and just require what you need for that specific agent and then specify every single request or RPC, as the case may be, is going to be dispatched to a brand new agent. So this is not working here, probably just because this is a pre-release version, but that will definitely be working by Golem 1.4 release, which is in just over a week. Okay, so in the absence of phantom agents, basically these constructor parameters uniquely identify that agent inside the Golem cluster. In the presence of that phantom flag, if you will, I'm actually allowed to have many different agents, all with the same constructor parameters, which is useful for AWS Lambda type scenarios where you want every new request coming into the system to be handled by a unique agent. And then there's also, I mentioned very early on that Golem gives me durable state and transactional code execution for free for all my code. Sometimes I don't want that. Sometimes I actually want sort of traditional, fragile semantics that are not fault tolerant when I deploy some type of agent. And what I mean by that is the state is not durable. It's going to go away if there's some sort of problem. And also, if I have a bunch of lines of code executing, it's possible that there's a failure event somewhere in the middle, and I don't want it to have the guarantee that everything is going to be executed. So there are a bunch of different reasons why you might want that, but the main one is just performance. So you don't want to have to pay for the cost of automatic fault tolerance and durable state and transactional code execution unless you really need it. So if you don't need it, why would you pay for the cost? There's actually a way you can specify that in the SDK here, and that's through mode. And you have two mode types. The default is durable, but you also have ephemeral. And let me go ahead and redeploy this and show you the difference. So now I haven't changed anything other than making this agent, counter agent, ephemeral. And deploy is telling me what's going to be changed. Basically, the signature of nothing has changed. The only thing that's really going to change is the binary. I'm going to go ahead and update this, delete existing agents, and then I can start the REPL. I can grab one of my counter agents. And I can see incrementing has no effect. And that's because every single time I try to increment, it results in the creation of a new agent. So this agent is not durable anymore. It is ephemeral. So again, you use this more as front-end entry point to your API. Okay. So other notes, you actually get a free API out of all of your agents. And you can interact with, you can programmatically construct agents and talk to them, dispatch to their methods using this free REST API that accepts and produces JSON. However, that API looks a certain way. It's mostly designed for tooling, like the CLI, for example, or Golem console or Golem desktop. It's probably not what you want if you want to use that inside of a mobile app or web app or some other use case like that. You probably want your own custom API. And currently, you would specify that API inside YAML. And you can see this one has an API. I won't go deeply into that now. I might have to spend some time later. But just keep in mind, you do have these APIs. They can look any way you want, these custom APIs. And in Golem 1.5, you'll actually be able to specify that in here in TypeScript just by adding another little decorator to these things. Okay, so I think that's it. I think I've showed you everything I need to, so you have some basic understanding of how Golem works and also how I might solve this problem. So what I'm going to do is just review these requirements real quick. Okay, so scalable NoSQL database in TypeScript. And there's a whole bunch of stuff here. And we can see how in some way Golem is going to make parts of this problem easier. Golem is open source. We're just going to use Golem. So that's automatically going to be checked. Leverage RAM, but fall back to disk to minimize cost. As long as we structure this solution in the right way, we'll get that for free from Golem. Why? Because any agent that's not being used is put in cold storage. And furthermore, if there's too many agents in memory and there's not enough for another agent to come into memory because, all the memory is consumed and our Golem cluster is not big enough, then one or more of those agents is going to be put in cold storage. So as long as we're careful to use the right architecture here, we're going to get this one for free. We're also going to get consistency and highly availability for free. So Golem right now is currently designed to be deployed inside a single data center or region, and not across regions. So there's stuff you could do if you really wanted that, or if you wanted replication across regions, you could do that. But right now, Golem makes the trade-off in favor of consistency and availability rather than partition tolerance. And then this is something we're on our own for. We need to support point lookups and enumeration, but surviving the loss of any node, that's something Golem gives us for free. So if a node goes down in Golem, it doesn't actually affect agents that are executing. What happens is a supervisor sees, oh, that node went down, and I need to take all of the agents that were executing there, and I need to scatter them across the remaining nodes, put them on a healthy node, get them back up and running exactly where they left off, with all of their state intact. So that happens automatically in Golem. It's not something you have to engineer for. If there are failures or restarts or whatever inside a Golem cluster, then things just from the outside, they look like your agent took a little bit longer to get stuff done, but it doesn't do any duplicate work because of transactional code execution, and it doesn't lose any data or state because of durable state. And then horizontal scalability, again, assuming we're choosing the right architecture to build this NoSQL database, then we could potentially get this one for free as well. So our job is to basically choose the right architecture and then also to support point lookups and enumeration. But what I'm going to do first is design something that I know to be bad design. I'm going to choose a really bad architecture here. And the reason is it's just better to have something that works than to have nothing at all. What I'm going to do is create an agent called table. And it's going to have a table name. And it's going to store data inside a map. So I'm going to be going for a basic key value store here for my NoSQL database. Maybe we'll have time to make that fancier, but for now, we're just going to start with a basic key value store. So I'm going to choose a map of string to string. And that's going to, anything can be stored in the string. So basically, this is just sort of a key value store where both the key and the value are opaque from the perspective of the database. Doesn't care what you store in it, as long as you can encode it into a string and then decode it from a string when you get back the key. And what I'm going to do is I will have a method that sets a key with the given value. And also I'll have another one to get the key from a given value. And actually, I don't want to use this. I think I want to use no. Or maybe. Okay. So I'm going to use null here. I want to optionally get back a string if it's already been stored. Otherwise, I don't want anything. I'm going to delete this old code here. And this no longer applies. That was just an example anyway. Okay, so now I have a table agent. The constructor gives it a table name. So what do we know about how this affects distribution inside a Golem cluster? We know that for any given table name, there will be a single agent of that type that we can connect to and we can talk to its methods on. So that has some implications I'll get into later. For now, I just want to get this working. Deploy it. Looks good to me. You can see here, we've deleted our counter agent with that method, and now we're adding a table agent with that constructor in these two methods. Seems correct. Oh, right. And then I have this custom API here in my manifest file. I'm just going to delete this for now or comment it out for now. Maybe we'll add an API later, but the API for the counter agent doesn't make sense. This new table agent. So we'll just retry deployment. Okay. We have it. Go ahead and test it out with the REPL. We'll create a table, or rather we'll connect to a table agent. We'll set the key A to be B. And then just to make sure it's working, we're going to get back that same. And we see it's some B. If we try to get back C, then we'll get back none. So again, the REPL has its own way, because it's using a scripting language called rib, it has its own way of factoring this, but this information is ultimately coming from my TypeScript code here, which is specifying that this is an optional return value. It could be string or null, and the null gets translated to none, and the string gets translated to some. All right, so I have a NoSQL database here, and it has some of these properties, but it definitely does not have this one here. It can survive the loss of any node, but it is not horizontally scalable. And the reason here is, if I quit this and access it again, get my agent, you're going to see that it's all durable, right? But I'm talking with an agent that is living on a single node inside the Golem cluster. And as a result, its scalability is limited to whatever sort of information and CPU I can get from that single machine. TypeScript is single threaded. So we're going to have one thread. And we have only so much memory. I can't remember exactly how much memory, but we only have so much. And after a certain point, obviously, it's just not going to be tenable to sequentialize or synchronize all reads and writes to this NoSQL database that exists on a single machine running in a Golem cluster. That is not scalable. It's not horizontally scalable because the data is all located on a single VM, on a single node. What we need to take all of this data and we need to chop it up into little bits and distribute that data across a Golem cluster. How do we do that? Well, we do it through agents and constructor parameters, because a constructor parameter is, in some sense, the way to look up the location of an agent in the Golem parameter. You can add more parameters here and make more agents and take the entire state of this NoSQL table and distribute it across a Golem cluster. And the first way I am going to do that is by creating something called a key value agent. And my key value agent is going to take in its constructor, well, actually, let me just mention the properties. The read-only properties are going to be a table name, but also a key name. That's going to be read-only. That's not going to change. And then I'm going to have a value here, which will be this mutable property that could be either string or null. And then in the constructor, I'm going to initialize my read-only properties. And then I'm going to have a get function here that is going to return this value, which might be null. I have to reflect that in the type. And then I'm going to have a setter that just updates the value. Now, this is my key value agent. And I'm going to actually use this agent from within my table agent. Okay, and what I want is I want every key value inside my NoSQL table to be stored in a different agent. Why? Because that's going to let me take the whole state of the NoSQL table and distribute it across a Golem cluster. Agents are distributed not quite randomly, but they are distributed uniformly across a Golem cluster. And so by creating one agent to hold every key value pair, I'm taking my entire state space and I'm chopping it up into little bits so that I can achieve that property of horizontal scalability. All right, let's see here. I need to update this. I'm going to store the table name here. I'm not going to store any more data inside the table. I am instead going to, inside here, locate this agent across the Golem cluster by using get. Now I have a key value agent in my hand, and I can, using this type-safe RPC, talk to it and tell it to do things. So I'm going to say set value, and this is async. It doesn't need to be async, but it is. So, okay. So I've just located the agent that is holding the value associated with this key. And I've just called the set method on that to store that piece of information. And then I'm going to do the same here for get. And that should be it. Okay, so let's go ahead and give this a try. Now, there's one more change I want to make. Note that this agent is totally stateless. It actually doesn't store any information. So what I'm going to do is I'm going to change this from being a durable agent to being an ephemeral agent. And I'm going to do that by altering the mode to ephemeral. And what that's going to ensure is that every time I construct an agent of this type initialized with some table name, that's going to be a new agent. Or rather, it's going to be an ephemeral agent, so not durable. There's no need to pay for the cost of durability. And what I would want to, in addition, is also say that every time you talk to one of these agent types, it should be a phantom agent. Why? We want a new table agent. Every time you interact with or talk to this table, we want a new phantom agent. I can't quite do that just yet because Golem 1.4 is not out, but that's how I would structure this. I would say not only do all these agents need to be ephemeral, but they also need to be phantom agents. So let's just pretend this is a phantom agent for purposes of this demo. What I'm going to do is redeploy everything. I definitely want to reset it. I've changed the way I'm structuring information here. So there's a big, big, big incompatible change. So I'm going to reset everything, blow away all of the agents that previously existed. Looks good, looks good. And now I'm going to enter the REPL again. And now I can see I actually have the table agent, but I also have this key value agent. The one I care about is table because the key value agent is being used by the table agent. I'm not going to use that directly, although I might show you what it looks like. And what I'm going to do is table get a reference to one of these, call set A, B, B to C, C to D, and then I'm going to get them. Let's get C here to make sure. Okay. So it's working. It's working the same as before, actually. I haven't changed the interface to my table agent. I only changed its implementation by adding this key value agent. So let me exit the REPL and then do an agent list. You can see what my interactions have done to the agents running in my Golem cluster. I have 4 agents. I have this one here because this one's not a phantom agent. This one really needs to be a phantom, but again, wait for Golem 1.4 if you want that to be a phantom agent. This here is the key value agent storing the value associated with the key C. This is the key value agent storing the value associated with B, and that one is the one storing the value associated with the key A. So I would expect 4 agents. I see 4 agents. You can see this is working. You can also see that this has now become horizontally scalable. Assuming this is a phantom agent, I've now created something that's horizontally scalable. Why? Because every single key value pair is stored in a different agent, and Golem distributes agents automatically uniformly across a cluster. So if my cluster is 100 nodes, for example, then I actually have an ability to host millions of different agents across that cluster. And actually many more, but millions of like concurrent agents. And there could be other agents that are stored in cold storage that will be rematerialized when I interact with them later. Okay, so are we done yet? Well, certainly not. So we have achieved horizontal scalability, but not in the best fashion possible. Why? Because we are storing with all of our key value, or data agents, if you will. So we're storing data inside this type of agent. We've achieved horizontal scalability, but we've done it at such a fine level of granularity that there's going to be overhead associated with interactions in our NoSQL database, right? Because anytime we're going to get our set of value, we're going to talk to the table agent, which is going to look up the correct key value agent, and it's going to get and set on that. If we have a big NoSQL database, then probably that agent was put in cold storage. It will have to be rematerialized into memory and CPU, and then we'll interact with it. We won't see all of those ugly details. Golem takes care of that for us, but we'll see increased latency. What we would like to be able to do is go from a world in which we are storing every key value in its own separate agent to a world in which we're batching a bunch of those together. We're bundling a bunch of those together. We're sharding our state space, not at the level of every key value, but by batches or groups of key value pairs. So in order to do that, we need to adopt a more sophisticated design here. And we're going to have to move from key value to something called, I'll call it a shard. It represents a shard, a piece or sliver of the overall state space. It's not going to be associated with a single key. It's actually going to be associated with a map. So a whole bunch of keys and values. And a table name is not sufficient here. I need some concept. Basically, I no longer have key. I need some concept of shard identity. We want to give every one of these agents its own unique identity. And that identity, the shard identity, combined with the table name, are going to uniquely determine the identity of these shard agents inside a Golem cluster. So without spending too much time thinking about what this is or should be, I'm just going to add it here. Okay, so now I have a table name here and a shard ID, and I want to use those two to locate these agents inside a Golem cluster. And I'm going to just straightforwardly update all of these. This is just using the map here. Okay, so now I have my basic shard. storing all of this information in the map. And now I need to use it from inside table, which means that I need a way to assign a shard ID based on what I have across both of these, the information I have across both of these methods, which is the key itself. So the way I want to do this is I want to take that key and I want to map this key into a shard ID in such a way that there are lots of collisions. So I want a bunch of different keys to map to the same shard ID. And there's multiple different ways you could do that. The way I'm going to use is I'm just going to add a library here. I need to add a library that can hash the key. I'm going to hash it, and then I'm going to take some prefix of that hash, and I'm going to use that prefix as the shard ID. So I'm going to switch over to the console, and let's just see. I'm going to go into my components TypeScript directory, into that directory. Okay, so I'm right here, right inside this directory. And then I'm going to add the name of this library called tsmd5. Okay. So I've added that library, so I should be able to access that inside here. Let me just make sure. Okay, it seems to be working. Now, the fundamental problem that I'm trying to solve here, which I'm going to pull outside the agent is the thing that Golem sees and the thing that other agents see. So you don't want these to become monstrously big. You can and should pull the vast majority of your application outside the agent. So I'm going to have a function here called, yes, that's fine, get shard ID. And I'm going to compute the hash as my first job, which is going to be md5 dot hash string on the key. And then I need some way to, that would do it. What I want to do here is I want to extract some portion of this hash and parse it as a hexadecimal int. So this hash string will come back as a hexadecimal int. And I want to parse that as a hexadecimal int. This is too much, actually. I think I need to substring it. Take the first, let's say, 8 characters in this hexadecimal string and parse that as a number. I don't want it to overflow the number type, so that's why I take a subset of it. And then I do modulo num shards. So this operator here will divide this number by this number and give me the remainder. The remainder will fall strictly between 0 and num shards minus 1. So it will allow me to effectively go from the key to a deterministic shard ID given a certain number of shards. So it's basically allowing me to map the space of all possible string keys into a number between 1 and num shards minus 1. It allows me to answer the question, if I want to look up where the value associated with this key is stored, then which shard ID do I use? That's going to give me back an int that I'm converting to a string. And now I have what I need. I'm actually going to make a helper function here, which will get me back it's going to get me back, let's see, shard.get of this table name and get shard ID. Okay, so it's taking this key, it's converting it to a shard ID, and then it's retrieving the shard associated with this key with this shard ID by using this RPC get constructor, which takes the constructor parameters of shard, which are the table name and the shard ID. Okay, so now I think I'm in business. I'm ready to get back a shard. And right now I'm hard coding this number of shards to 10. And once I get back the shard that contains this data, right, so we need a key here. We need a key here. This was AI gen code, which is why it's wrong. Okay. So now we're looking at the data in this map by the key that was passed into us, and we're setting it by the key that was passed into us. So this code is now correct. So this is type checking down here, and then we'll do the same thing here. Okay. So we get the shard, and then on this particular shard, which contains all the data for that shard, we set that key value. All right, I think we're done. Let's go ahead and deploy this. Another hugely incompatible change. So we're going to reset the state. Now, actually, because we've not changed the interface of table, our interface of table has remained the same. There might be a way we could upgrade this as we went along, but we would have to do more work. So it's easier just in development to just blow away the state. Golem has several different ways of doing updates of code while keeping state intact. One of them is sort of an automatic upgrade, and then another one is a custom upgrade. We could explore that, but I think the simplest thing to do here is just to blow stuff away. Okay, we deleted all the agents that existed. And now we're ready to test again with Golem REPL. All right, so this is what we would expect to see. Let's go ahead and create one of these table agents. And now we're going to do set A to B, set B to C, C to D, and then we'll just make sure that we can retrieve this information from our database. And make sure we cannot retrieve information that's not there. Everything's working fine. But it would be nice to do some sort of sanity check. So let's exit the REPL, and we'll do a Golem agent list just to see what's in there. All right, we've got 3 shards. And they are one with the shard ID 0, one with the shard ID 3, one with the shard ID 7. So it is hard to tell, is this right or not? Well, it looks correct to me. What we're seeing is that our hashing is somewhat uniform, at least with this small sample size. It looks relatively uniform. We don't have a bunch. We would know it's definitely wrong if we had all of these key values being stored in a single shard. But we actually see that for 3 keys, this information was stored across 3 separate shards, which makes sense to me. That's what I would expect. Obviously, as we keep on adding more and more information to our database, then we're going to see all of the shards. We'll see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 shards here because I hard-coded that number here. So we'll see all 10 shards be created, and each one of them will store information. Let's go ahead and add a, just so we can see what's going on here. Let's add, we'll add a locate method to table. And my intention with this one is just to use a key to look up a shard and have this shard will have the this table function look up a shard corresponding to this key and just print out some information that can allow us to see what's going on inside here. And I'm going to use a console log here, and we're going to print out all the information we can. And I think that's it. So let's go ahead and rerun this. We'll redeploy it. Open up the REPL. And then we'll do t.diagnostics of the shard containing A. I get back some error. Not sure what it is. Let me just make sure I didn't misspell that right. Did not misspell that. So what I'm going to do is just make sure I've blown away all of the temporary information inside Golem. Diagnostics for the key A. And that worked. Oh, I didn't, I printed it out in that agent. I actually would need to, here, let me exit. I'm not seeing that log message because I connected with the table agent, not the shard agent. So if I really want to see that message printed out, then what I need to do is grab one of these. Okay, so I can see here that there's a shard 0 and a shard 7. Let me start the REPL again. Okay, there we go. So I've connected to this shard directly so that I can see this, all of my console log messages and so forth that I put inside my agents. When I connect to those agents, I'm actually going to see them inside the REPL. So here I can see I printed out a bunch of stuff. 2 entries here, and the data in shard. Well, this is just because I need to format this information in some way. But there's I'm just getting the default 2 string here. I need to format the information in there in some way, which I'm not doing. But you can see the point here. I'm able to inspect these things just by, well, either adding methods or by just inserting log lines. And I'm going to see that if I'm connected to the agent, I'm going to see all of the log lines inside the console. Okay, so what now? Well, let's go back to our requirements. Are we horizontally scalable? Yes, we are in a good way. We're horizontally scalable in a good way because how the data is being distributed is no longer by table. That was bad. That was not scalable. It's actually and it's not by key value, which worked and gave us horizontal scalability, but there would be performance implications for storing every key value pair inside its own agent. That would be a bad way of achieving scalability. What we want to take advantage of sort of locality and a freshness of these agents by bundling a bunch of keys into the same agent. And that's what we did by introducing this notion of shard. Now we have a shard here with a table name and a shard ID, and the shard ID is going to be a number between 1 and n minus 1, where n is the total number of shards. We pick what the total number of shards is. So in this case, I picked 10. This is not a good number to use in general. I'd say if I were designing a scalable NoSQL database, I would need to know exactly how scalable it needs to be in order to pick this number. I'd pick a number greater than 10 then. I would probably pick 100 or 1,000. Who knows exactly what I would pick? But you can view each agent as almost like being an invincible server or an invincible node, right? It's like a node of a virtual computer, a virtual node. It's not going to go down. It's going to have all of its state, et cetera. I don't need to worry about it. I want to choose a number of them so that I don't have hotspots and so that I achieve good cache coherence, really. So if someone grabs this key, that's in memory. If someone grabs this other key, well, it's still in memory, et cetera. And I have optimal performance. So we'd have to tweak this number in order to discover what the right number is. But actually, we don't really need to do that, right? Because one of the improvements we could make to this design is we could opt for a dynamic number of shards. We could start the problem with 10 shards and then, have a load method here, basically, that tells us how loaded these shards are. And as this map starts to get too big, it's going to cross a threshold at which we're going to decide we need to reshard this information. At that point, we would deploy new shards and we would copy over all the information and we would redirect traffic in a way that makes sense. So we could actually do that. I'm not going to do that because I don't have confidence I can finish it in 40 minutes. However, that is something that would be possible, and you could do that sanely in Golem, is sort of dynamically resharding based on actual load. What are some other improvements we can make? Well, we've not satisfied all of the requirements of this solution. Why? Because we are horizontally scalable. We do survive the loss of any node. We support point lookups, but not enumeration. And then we already checked the other parts. So the real part that we're missing here is enumeration. It would be great if we had a way to enumerate the contents of any given table through the REPL or through a custom API that we would later add inside this YAML. So how would we do that? Well, we need some piece of information which you could think of as an iterator. I mean, fundamentally, we're enumerating, right? So we're looking for an enumerator or iterator of some kind, but that enumerator or iterator, it needs to be reified. We have to turn it into data. We have to have a concrete data representation for that, because we can't have like mutable iterators in rib. That doesn't make sense. You can't return an iterator here from one of your functions. That's not going to work. You can return a lot of things. You can return all pure data types, but an iterator is not going to be a pure data type. It's going to capture over state and do all this other stuff. So we're not going to be able to return classes and other types of things from our agent methods. So what are we going to do? We're going to convert that iterator into data. So we need some sort of data representation of an iterator that allows us to keep track of our progress in enumerating the key value pairs of this table. And there's sort of a dumb way I can think of doing it right now. And that dumb way would be with have maybe a type here that has a shard ID, and it needs to have some other piece of information. If we're iterating across all of our shards and showing all of the key value pairs in each one, then we need to keep track of not just the shard ID that we're currently at. Actually, this will be a number, but also like a current key. Something like this. I think this is the correct representation for a shard iterator that is well defined. It's not the only way we could define a shard iterator. We could also we could also define this as an index and say that the shard iterator represents a location by shard ID, and inside that shard by the nth entry inside that map. However, the reason I think that's not particularly well defined is because these maps here, I don't think are going to, I don't think that they're going to be stable. Yeah, for sure not, because as soon as we add a delete key here, then you could delete a key and that would result in you skipping an entry. So you could iterate over the entire database and you would not see everything. You would only see a subset of data. Now, you might argue that's fine. Maybe, in fact, we start with that. I don't know. Maybe we start with that solution. Another way is just to say, we're going to give you the data back in batches. And your iteration is only going to be shard ID. So you're only going to iterate over the shards every time you get back the data. I don't like that idea because it's basically saying you need to ultimately be willing to look at all of the data inside the database if you want to do iteration. And I feel like that's not enough. Ultimately, you would want to add some sort of filtering. You would want to add indexes here so you can do quick lookups of information by some sort of attribute in the key or whatever. You would at the very least want to be able to iterate through a well-defined range of keys inside a single shard and not have to pull back all of that data over the network to get the 3 values you were interested in. I think that's a dead end. Maybe I'll start with this approach and just see how it works. We can do better than this, but I don't think we can do significantly better than this without changing our representation of how we're storing this data. We actually need we need to store it in actually a tree. I think we need like a tree map that stores by sorted key order. And if we have that, if we have all the information in this map stored by sorted key, then we have a well-defined iteration order that's going to be stable to addition and removal of new entries. So as we're adding and deleting stuff inside this tree where everything's sorted by the key, we're always going to be able to say we want to start our next iteration, our next batch, or next page of iteration from this particular key and go onwards. And that's going to give us a stable, well-defined way to iterate over the contents of our entire NoSQL database in a lazy, efficient way that's going to be future-friendly if we want to add things like filtering and indexes. But for now, let's start with the simple representation. So how do we want to do this? So one very simple way, I think, is just to let me pull out this number into a const. And that way I can use it elsewhere. And I can say something like, what would I like to say? I would like to say something like iterate, which gives me a shard iterator. And return a initial iterator that is always going to start from the current shard, and it will start from the first entry in the current shard. And then I need some sort of way to advance this. Do I need a function that looks like advance, which takes as input the existing iterator and returns, I think we would want, what would we want here? I think we would want both the next something that returns us a batch or a page of information, as well as the next sort of place where we're iterating the marker or whatever you want to call it. Okay, so we're going to get, let's see, we need to do some basic validation. So actually, we probably want to make this optional because we want to say that if iterator shard ID is greater than max shards, then we return an empty array as undefined, saying we're done. Probably we would also want to say if iterator shard ID is less than 0, then we do the same thing. or maybe not. Maybe less than 0 should be taken to be an error condition, but I'll just use that for now. And then let's see. Otherwise, we're going to, that's our shard ID. So it occurs to me I've been treating shard ID as a string, but it actually is a number. I'm going to make that change here. Okay, so now we're going to, actually, we don't need that, right? We need table name and shard ID, which is a number. So we're just going to do shard.get this.table name. We know the shard ID is valid. So we're just going to use it. And then we've got to do, got to add a method here to return all of the data after a given index up to a certain limit. So what we'll do, we'll do this. Skip past the first offset number of entries until offset gets to 0. And then when offset gets to 0, we'll continue past that. If the limit is less than or equal to 0, we're done. Otherwise, we'll push. Oh, we need to push, actually. We need key value pair. And I'm getting my syntax wrong. See, key is a string, value is a string. I need an array of tuples.
I think the typing of your result type is conflicting because you just typed it as a string array,
Right.
not an array
Yes.
of
So
tuples.
my problem is here, right? Okay. So I get a page worth of data. We can't access this directly because in agent-to-agent communication, it's all RPC. So the contents of this agent are actually not transmitted to the other agent. We interact only with the methods of the agent. So we have to have a way to get the information we need from that agent. So the RPC call will succeed. So we have page with offset here and limit. Go ahead and see if we can use that here. So we'll do start page. We're going to start from index. And we're going to retrieve I don't know how many to return. Maybe for now we would just return one. I'll make it a bit simpler, iterating one by one over them. And we would start at iterator.index, and we're only looking for one. And we can say, well, result equal to null. And iterator shard ID is less than max shards. And we'll try to get this. We'll try to get a single result from this index. If the result length is less than 0, then that means we need to reset the index and increment the shard ID. So we increment this, and this actually needs to be, just one. Okay, and then we're going to move this inside here. So we get this particular shard using iterator.shardID. We try to get back a single result starting at our current index. And if the result is less than 0, or sorry, result. Why is that that's right. So we're looking for a single thing. So if the length is less than 0, it's going to be less than 0, or it's going to be 0, or it's going to be 1. Those are the only possibilities. So if it's equal to 0, then that means we didn't get back anything, which means we have to reset the index and go to the next shard ID. And then that should be that. And then here we do, we need to do, right. So otherwise, else result is equal to, we have key value. So this actually needs to be a string people. So this is going to be results. Just call that results. And that way it won't conflict with the singular result. And then result will be set equal to, right, I'm getting an undefined here from, somewhere.
Because you use the question mark for optionality.
Oh, for here, right, yes. An optional shard iterator, right? So I have.
You can just use undefined everywhere where you are using null, and Golem will treat it as an option type as well, if you want.
Okay. I have another problem here, which is this is promising to return. I need to move this question mark outside, I think. And this should be a tuple. Should be the key and the value and the iterator all optionally. So I would return undefined here. And then this would be actually Okay. No. Okay, so if this does exist, well, first off, I need the next shard iterator. So I need to compute that. I need to say if no, I'm not gonna, I wanted to make this a little fancy. I'm just going to return because I'm going to involve duplicating logic here. So I'm just going to return basically this. And it's possible the iterator is empty, in which case you won't find it out until it thinks that this is going to be undefined. Thinks the array is going to be undefined, or this tuple might be undefined. I'm going to cast that problem away. And then down here, I'm going to return while result is equal to null. Okay, so it starts out being null. It's going to iterate one time. It's going to continue for as long as the shard ID is less than max shards. Actually, that's correct. Because this is our shard iterator. It's going to go through all the shards until we find one that is
You
not
can
empty.
actually, sorry to interrupt, but you can use the exclamation mark postfix to
Here.
make it know that it's not nullable. Yeah.
Perfect. Okay, almost there. There. Okay. So let's just double check this logic. If the shard ID is less than 0 or it's greater than or equal to max shards, then we say we're done. On the other hand, if it's not, then we start off assuming that we're done, and then we begin this loop that's going to execute until we find something or until we run out of options. So if we find something, we'll terminate the loop, but also if we've run out of shards, we'll terminate the loop. You get back the shard corresponding to this shard ID. We try to pull back a single entry starting at the current index, which could fail. Hopefully this only fails in good ways. I think that's true. If the results it's going to be 0 or 1 because we've said 1 is the max. So this is going to be 0 or 1. If it's 0, then that means that shard has no more data starting from that index. So we go ahead and reset the index and increment the shard ID. On the other hand, if there was a single entry in here, we extract it. And we're forcing that result. We know it's safe to do because we've already made this check. And then we snapshot the value of this iterator, which has its current updated index and shard in there. And then we return the result, which will contain the tuple of those two things, the key value pair and the shard iterator. So I think that's correct. You see any bugs in it? Go ahead and redeploy.
Just as a remark, you often don't want to do the triple equality for null, because this will be strict for only null and not null and undefined. And if you're
Right.
missing them in other places.
Makes sense. I fixed that. Okay. Now we're going to go ahead and fire this up. Got a bunch more things here. We'll put some test data here. Oh no, because I updated a bunch of things, I'm going to have to. I think I'm going to have to reset. Oh wait, I'm not running Golem. For whatever reason, I'm not running Golem. So let me reset the REPL.
Golem only works if you are running it. That's a limitation.
Okay. All right. Just verify that's working. Yes. Okay. So now I want that iterator. What did I call it? Iterator. Iterate. I'm surprised that I get back nothing. I should be getting back this record containing the shard ID and an index. Oh, right. I did let. Right. Of course. Okay. So that's my initial iterator. So let me go ahead and call tAdvance with this initial iterator. And I get back B, comma C. And shard ID 0, index 0. That's not correct. And that's because I failed to update the index in this branch. So if we pulled something out of there, we've got to plus the index. Bug. I'll just go ahead and redeploy. Iterate. Okay. Advance. Starting from the initial iterator. What?
Did you upgrade the worker or use the reset flag? Maybe it's still running the old version of the code.
All right, just in case it's still running the old version, I'm just going to reset the server. Yes, there, finally, my fix in there. Okay, now I got the first entry, which was BC. That's not a bug. The order in which the entries are distributed across these shards is deterministic, but we don't have control over that process. So let's just make sure if we iterate the next one, we got back CD. Okay, so that means there's, oh, look, we skipped ahead all the way to index 2. And then we jumped ahead to shard ID 7. So there was nothing stored in shard IDs 1 through 6, and it's only shard 7 that has the next one. And then let's see what happens if we continue from there. That's it. So we saw 3 entries, and we saw those entries at shard ID 0. There's 2 things in shard ID 0, and there's 1 thing in shard ID 7. It's easy enough to confirm if that's correct by doing the agent listing. Okay, well, we've actually created all the shards. So it's no longer simple. My act of iterating over all these shards has materialized them, so it's no longer simple to see what they have inside them. But I think that, actually, let me just go back into the REPL and verify. So shard 0 has 2 entries, and the other one we said had a single entry, shard 7. And that has 1 entry. So everything looks like it's working correctly, and just in time, because I only have 7 minutes. So let's see, how could we get more ambitious? Well, the next obvious thing for iteration is to use a beat tree. I took a quick look. There's a TypeScript library called sorted B tree. And that sorted B tree one would allow us to store the data in sorted order on every shard so that we could have a sane iteration semantics. This is not sane iteration semantics because in the presence of concurrent modification to the data on all these shards, when we iterate over the entire database, we're going to miss data that we could have actually spotted. Now, because this is a system that's continuously evolving live, we're not going to get consistent iteration. We don't necessarily need consistent iteration, but we want to make sure that we don't miss things that we know to be there at the moment where we're iterating over that shard. We're failing to do that now because we're using an index to represent our location. And also because of that, this is not scalable. The cost of doing this, of looking up the ith index or the ith entry in a given shard, is actually big O of n, where n is the number of entries inside that map. So this is not a scalable solution. We need to fix this problem. A sorted B tree is the correct way to fix this problem, as well as to give a sane iteration semantics and sort of weakly consistent iteration semantics. It's consistent with respect to a given shard at a given moment in time. We're not going to miss things that we know to be there if we switch over to using the B tree. So I would definitely make that change to improve the iteration. This one, fortunately, I gave myself a way out. I just said point lookups and enumeration. I didn't say how fast this enumeration had to be, or if it had how consistent it needed to be. So I was able to implement that in the provided time. It's just, this is not a production grade implementation for the reasons that I mentioned. The other thing that I would definitely do is consider adding dynamic rebalancing. Right now we are fixed to 10 shards, and where we really want to be is support a varying number of shards based on the total amount of data inside our NoSQL database. After we've got ranged enumeration working, which is probably an hour of work at most, maybe 30 minutes of work, and we have dynamic sort of resharding working, which is more work, probably an hour or 2 of work, then we're going to have something that can scale up in the number of these shards, scale down as necessary based on actual load, and we'll have really useful iteration semantics that have performance characteristics similar to how you can do iteration on S3. You can do iteration on S3 buckets, by key name, and that's very efficient. And we would have a similar level of efficiency here for enumerating over either everything in all of our NoSQL table, or maybe just a range. Maybe we want to start here and in there, both of which I think could be done in another 2 hours worth of work, or maybe 3 hours, because of the resharding that has some complexity. We could probably get it to the point where it actually represents a reasonable take on a NoSQL database. The other thing that would be interesting is to take a peek here and see if we can add some APIs. And actually, I already went through and added some APIs, or sketched up some APIs anyway. Sketched up some APIs just so I wouldn't have to take the time to do that in here. And basically, I added a route, which is table name / keys. And actually, I'm going to call this get. Or no, maybe, I'll call it get. And this one I'll call key / set with a query string value. And I think this is all the same, more or less. Yeah, table agent. See if this actually deploys. There might be some problem. No obvious problem. Okay, so in theory, I now have 2 routes here, which allow me to, this script in code here is talking to specific agents. So now I have a little REST API. Let me actually see if I can. I'll open my browser, my table C. Keys, and then just a key of A. I get null, okay. And if I do A / set, value equals B, then I get back that message, which actually comes from this little script here, which is adding this custom API. And now if I get back, I do a get to A, I see there's a B. So now I have a custom REST API on top of my NoSQL database, which is directly talking to the agents. Again, you don't need to do this. In Golem 1.5, you'll actually be able to do it over in TypeScript world just by adding your routes here. But until then, you can use the rib scripting language to quickly add custom APIs that have any sort of shape that you want. And they can directly talk to agents in your Golem cluster. So you can take the functionality you've made in Golem and expose it to the outside world. Okay, well, I did it just barely and by cutting a few corners, but hey, you do what you have to do in order to ship working software. We now have a beginner NoSQL database that nonetheless solves the most challenging aspects of building a database, which is the distributed system, the reliability in the distributed system component. We're horizontally scalable. We can survive the loss of any node. We're consistent, highly available. We leverage RAM. We fall back to disk when necessary. There's no proprietary software here. It's all open source. And of course, we support point lookups and enumeration, all in a tiny amount of TypeScript. And this amount of TypeScript is not really concerned at all with infrastructure. We don't have to concern ourselves with robustness or resilience, reliability, infrastructure failures, network communication errors, like all those things, they're gone. In Golem, RPC is always reliable. It's always guaranteed. An agent will always succeed in talking to another agent. Our agents will always execute to completion. Everything that is stored in memory will always be there and available. We don't need to consider any of that. So what it does is Golem takes all of the really, really hard aspects that are inherent to building any distributed system and just makes them fall away into the background. And all we have to concern ourselves with is business logic, or in this case, database logic. But our database logic here is super clean, it's squeaky clean. I mean, we're focused on our business problem and we're letting Golem do the heavy lifting. Now, I don't recommend using Golem to build NoSQL databases because there's tons of distributed NoSQL databases out there, and they're very fast and they're written in systems programming languages like Rust and C and C++. So if you need a NoSQL database, use that. However, if you are building a distributed system, maybe it's agentic, maybe it involves using AI, maybe you need lots of orchestration of model inference, or maybe it's more data flow, maybe it's more workflow related. Maybe you're doing finance stuff where it's very mission critical and you can't afford to have some fault somewhere take down execution of your code or take down state, then Golem is a perfect fit for that. And I think as you've been able to see in the live stream here, our tooling has come a long way since last year, and it's actually really beautiful, very fast, has everything baked in, very, very easy to use, get started, and lets you get this really sort of test and develop loop that helps you be extraordinarily productive. So I hope you've enjoyed this live stream. I'm going to go ahead and switch over to Discord, make sure I haven't missed any questions. Doesn't look like there are any questions related to this. So thank you all for attending. And if you like this, give us a share on X or LinkedIn or wherever you're watching this, and tune into the next one where I'm actually going to use Golem to build an AI agent. The agents here are agents in a technical sense, where every agent has compute and state and is independent and autonomous and can sort of live its own lifespan and make its own decisions and whatnot. But in the next one, I'll actually build like an AI agent, which is all the rage these days. And you can see how Golem's durable state and transactional execution actually allow you to build very powerful AI agents that are reliable, very cost efficient, and can deal with the non-determinism inherent in use of model inference. So I hope you enjoyed this. Thank you also, Daniel and Maxim, for being here to catch all of my programming mistakes and my TypeScript stuff. I appreciate that. And I will see you all online. Take care.